The Arctic ice pack is the ice cover of the Arctic Ocean and its vicinity. The Arctic ice pack undergoes a regular seasonal cycle in which ice melts in spring and summer, reaches a minimum around mid-September, then increases during fall and winter. Summer ice cover in the Arctic is about 50% of winter cover. Some of the ice survives from one year to the next. Currently 28% of Arctic basin sea ice is multi-year ice, thicker than seasonal ice, up to 3 to 4 meters thick over large areas, with ridges up to 20 meters thick. As well as the regular seasonal cycle, there has been an underlying trend of declining sea ice in the Arctic in recent decades. Climatic importance. Energy balance affects sea ice has an important effect on the heat balance of the polar oceans, since it insulates the warm ocean from the much colder air above, thus reducing heat loss from the oceans. Sea ice is highly reflective of solar radiation, reflecting about 60% of incoming solar radiation when bare and about 80% when covered with snow. This is much greater than the reflectivity of the sea, and thus the ice also affects the absorption of sunlight at the surface. Hydrological effects. The sea ice cycle is also an important source of dense bottom water. While freezing, water rejects its salt content, leaving pure ice. The remaining surface water, made dense by the extra salinity, sinks, leading to the production of dense water masses such as North Atlantic deep water. This production of dense water is a factor in maintaining the thermohaline circulation, and the accurate representation of these processes is important in climate modeling. Odden. In the Arctic, a key area where pancake ice forms the dominant ice type over an entire region is the so-called Odden ice tongue in the Greenland Sea. The Odden grows eastward from the main East Greenland ice edge in the vicinity of 72 to 74 degrees north during the winter because of the presence of very cold polar surface water in the Jan Mayen Current, which diverts some water eastward from the East Greenland Current at that latitude. Most of the old ice continues south, driven by the wind, so a cold open water surface is exposed on which new ice forms as Frazel and pancake in the rough seas. Extent and volume of sea ice and the trends. Records of Arctic sea ice from the United Kingdom's Hadley Centre for Climate Prediction and Research go back to the turn of the 20th century, although the quality of the data before 1950 is debatable. Reliable measurements of sea ice edge begin within the satellite era. For the late 1970s, the scanning multi-channel microwave radiometer on CSat and Nimbus 7 satellites provided information that was independent of solar illumination or meteorological conditions. The frequency and accuracy of passive microwave measurements improved with the launch of the DMS-PF8 Special Sensor Microwave Imager SSMI in 1987. Both the sea ice area and extent are estimated, with the latter being larger, as it is defined as the area of ocean with at least 15% sea ice. A modeling study of the 52-year period from 1947 to 1999 found a statistically significant trend in Arctic ice volume of -3% per decade. Splitting this into wind-forced and temperature-forced components shows it to be essentially all caused by the temperature forcing. A computer-based, time-resolved calculation of sea ice volume, fitted to various measurements, revealed that monitoring the ice volume is much more significant for evaluating sea ice loss than pure area considerations. The trends from 1979 to 2002 have been a statistically significant Arctic sea ice decrease of -2.5% plus or minus 0.9% per decade during those 23 years. Climate models simulated this trend in 2002. The September minimum ice extent trend for 1979 to 2011 declined by 12.0% per decade during 32 years. In 2007, the minimum extent fell by more than 1 million square kilometers, the biggest decline since accurate satellite data has been available, to 4,140,000 square kilometers. New research shows the Arctic sea ice to be melting faster than predicted by any of the 18 computer models used by the Intergovernmental Panel on Climate Change in preparing its 2007 assessments. In 2012, a new record low of about 3,500,000 square kilometers was reached. In the overall mass balance, the volume of sea ice depends on the thickness of the ice, as well as the areal extent. While the satellite era has enabled better measurement of trends in areal extent, accurate ice thickness measurements remain a challenge. Nonetheless, the extreme loss of this summer's sea ice cover and the slow onset of freeze-up portends lower than normal ice extent throughout autumn and winter, and the ice that grows back is likely to be fairly thin. As more and more of the sea ice is thinner first-year ice, the greater effect storms have on its stability, with turbulence resulting from major extratropical cyclones resulting in extensive fractures of sea ice.